Okay, in problem number 83, we are going to use the same kind of trick that we did in problem number 75 with the change of variables. So I have here sine of x squared over x. There are two ways to do this. One is with our change of variables way, and another is exactly the same, but we don't use another symbol for our change of variables. So I'm going to show you the other way real quick. So we have the limit as x goes to 0 of sine of x squared over x alone, right? One thing that we can look at is say, hey, if this was squared, I wonder if I can change the color here. One moment. Okay, there we go. If this was only a square on the bottom, right, then the quantity in the denominator would be the same as the quantity in the sine function in the numerator, and then we could just say that this whole thing goes to 0. One reason for that is because x squared goes to 0 as x goes to 0. So, but we don't have that, right? What we are missing is a term of x in the denominator. But if we multiply the top and the bottom by the same thing, a quantity of x, right, then we would, right? This quantity of x, one factor of x would cancel in both the numerator and the denominator. So this is equal to the limit as x goes to 0 of x sine of x squared over x squared. X squared goes to 0 as x goes to 0, so therefore this would go to 1. So we have limit as x goes to 0 of x times the limit as x goes to 0 of sine of x squared over x squared. This quantity goes to 1. This quantity goes to 0, so we get 0 times 1, which is just 0. And that's the end of it. The other way to do it is really the same exact thing. You are saying, hey, this quantity that I am looking at in total, right, is, I'm considering that in my mind as one whole thing, right? Let's call it u. U equal to x squared. Then my quantity x is equal to the square root of u. The limit as x goes to 0 is 0, so the limit as, and so square root of u goes to 0 as u goes to 0. So the limit as x goes to 0 of sine of x squared over x is the same thing as the limit as sine of u goes to 0, right? This time we have a square root of u, and if we want to change that into sine of u over u, we multiply the top and the bottom by a square root u, and I get square root of u times sine of u over u, and we have the same kind of reasoning as we did in the previous example, where we say, okay, well, this quantity definitely goes to 1, so therefore the limit of this thing exists, and the limit as u goes to 0 square root of u just goes to 0. Again, this goes to 1, so I get 0 times 1, which is 0. So that's number 83. Number 85, it says in number 85 to find the limit as delta x goes to 0 of f of x plus delta x minus f of x divided by delta x. They give us as an example in 85 a function f of x equal to 3x minus 2. So if we evaluate f of x plus delta x, we just put in x plus delta x everywhere that we see x in the function. So the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x is equal to, well, substitute this quantity in for f of x plus delta x, and substitute our f of x in for, well, f of x. When you do your substitutions, you should remember that you're including that as a whole quantity, right? So the reason that I usually include my parentheses in for my substitutions is because of if I have these signs in front of it, that sign needs to carry through to every term inside your grouping. So, or inside of your substitution. So if I do my distribution, right, I get 3x plus 3 delta x minus 2, and then I distribute the negative sign inside of the second term, so I get minus 3x plus 2. Remember, the minus carries over into this quantity right here, so instead of being negative 2, it becomes plus 2. I have some cancellations here. I have a 3x that cancels with a 3x. I have a minus 2 that cancels with a plus 2. I'm left with only 3 delta x over delta x. The delta x's cancel. I am left with 3. Therefore, the limit as delta x goes to 0 of just 3 is just 3. And that is the answer. So in the next one, we will start with 87, and we're getting very close to the end.